Hello, today we are going to start our new lecture on the microencapsulation process. So, before going to details about the microencapsulations, first we have to know that what is the microencapsulations means actually. So, microencapsulations is nothing but it is a one kind of coating process. So, we can coat some kind of solid materials or maybe we can coat some kind of liquid materials, just giving a coating of any kind of polymer or maybe any kind of ceramic materials onto that, so that it can be surrounded by another material onto the substrate. So, in another word we can say that this is also a one kind of formations of the core cell structure. So, microencapsulations is a process by which individual particles or droplets, as I already told, these particles or droplets either may be in the solid form or in the liquid form, or solid or liquid material core are surrounded or coated with a continuous film of polymeric materials, the shell, to produce capsules in the micrometer to millimeter range known as microcapsules. So, from this particular figure we can understand that we are having some kind of matrix, then on top of that we are making a shell on another materials by which we are covering our base materials or maybe the substrate. So, this is known as the microcapsulations or maybe that microcapsule. The size of the resulting products ranging from 0.5 to 200 micrometers. So, it is controllable, we can easily control the thickness of that particular coating. It is usual to differentiate the microcapsule strictly speaking from the microspheres. The microcapsule are shell like systems protected by a polymeric membrane. So, as I told already, we are giving a coating of some kind of polymeric materials onto the substrate or maybe onto the materials which we are going to coat. The microspheres are matrix systems, that is products made up from phases dispersed in a polymer matrix. Now, when we are talking about the microencapsulations, first we have to know that what is the science behind it. So, how we are making that systems, how we are making the materials. So, the morphology of microcapsules mainly depends on the core material and the deposition process of the cell or wall. So, here you can see from this particular figure that inside generally we are calling it as a substrate or maybe it is our material which is known as the core material. On top of that we are adding or maybe we are providing a layer onto that which is known as the wall or maybe the shell material. So, here wall or shell material is the coating material and core material is that on which we are doing the coating. So, by method we can divide these parts into three different zones, rather one is called the mononuclear core shell. Microcapsules contain the shell around the core, it is like this. So, here inside is the core material, outside is the layer. So, that is why it is known as the mononuclear. Then polynuclear capsules have many cores enclosed within the cell. So, here this is the cell in which so many cores are enclosed, and the matrix encapsulations in which the core material is distributed homogeneously into the shell material. So, it depends upon how we are putting the filler inside. So, if it is a single material we are doing the coating, if it is a mixing of different core materials we are doing a coating, and if it is some matrix materials means like composites, and then we are making a coating. So, based on that we are having mononuclear, polynuclear and the matrix. In addition to these three basic morphologies, microcapsules can also be mononuclear with multiple shells or they may form clusters of microcapsules. So, this is like something different varieties. So, how depending upon our requirement, depending upon our applications, we can make different types of microencapsulations. So, it is a one example just I am going to give so that we can better understand that how we are doing the microencapsulations. So, it is a example of a constructions of robust organic inorganic hybrid magnetic microcapsules. So, here generally we are taking the polymer which is nothing but the polydopamine and Fe3O4 nanoparticle onto a calcium carbonate microparticle template which is known as the core material. Now, negatively charged Fe3O4 nanoparticles were absorbed on the surface or into porous calcium carbonate microparticles through electrostatic interactions and physical absorptions. So, in that calcium carbonate we are incorporating the Fe3O4 inside. Then the magnetic sacrificial templates were coated with PDA through the self polymerization of the dopamine to obtain the magnetic PDA calcium carbonate microparticles. Combining the merits of the organic layer and the inorganic component and the microcapsule were applied for the encapsulation of Candida rugosa lipase. So, this is a one kind of composite structure generally we are making by this coating technology. So, inside we are having that materials which is known as the calcium carbonate, in which we are inserting the Fe3O4, and then the whole thing we are making the coating by polydopamine or maybe the PDA solutions. So, like this way we can do this kind of microencapsulations for some biomedical applications or maybe some kind of magnetic microcapsules applications. Now, the fundamental considerations. So, as I told already, our core material can be anything, means in the form of solid or maybe in the form of liquid. So, now this coating materials is divided into polymers, waxes, resins, proteins and polysaccharides. So, as I told already, this kind of microencapsulations, the mainly applications is the biomedical purpose or maybe that medical applications or maybe that drug delivery applications. So, generally we are using this kind of materials as a coating materials like polymers, wax, resins, proteins, polysaccharides. Then coating material properties, these properties should have, means while choosing that coating materials we are taking care all these things into our mind. So, first one is called the film forming, pliable, tasteless and stable. Then non-hygroscopic, no high viscosity, stabilizations of the core material so that it can't change with the environmental conditions. Inert toward active ingredients, when we are inserting that materials inside our body, maybe some acid, maybe some base. So, it should not react with acid or base and it should do the proper justice inside our body. Controlled release under specific conditions. So, when the exact environment it will get, then only it will start acting or maybe it will be activated. Soluble in aqueous media or solvent or melting. The coating can be flexible, brittle, hard and thin. So, as per our requirement we have to choose the coating materials based on these properties. So, here we are giving some examples of that core materials. What are those? First is called the acetaminophen. So, generally this one is all the medical terminology or maybe that medicine names. So, simple the thing is that inside is our medicines, then outside we are giving a coating so that we are taking that medicines inside our body. The best example is that capsule. So, if you see the capsule, the outside is made by the polymers or maybe some kind of proteins or maybe some kind of materials which can easily digest in our body. Not only that, can be melted in our stomach, and inside actually we are putting certain kind of medicines. If we do not do like this, so we can't take the medicine directly in our stomach, maybe the medicine is too bitter or maybe it can't be tolerable. So, that is why we are doing the microencapsulations by some kind of polymeric materials and we are swallowing that medicines into our body. So, here the core material may be acetaminophen or maybe aspirin or maybe vitamin A palmitate, urease, progesterone, some kind of hormone, then isosorbide dinitrate, potassium chloride, activated charcoal, liquid crystals. So, here characteristics property, acetaminophen is generally solid, aspirin is also in kind of solid materials, vitamin A palmitate is non-volatile liquid, some kind of potassium chloride is highly water soluble solid. So, here we can see that either the characteristics of that core material may be the solid or maybe that liquid or maybe some kind of viscous materials. Now, purpose of encapsulations, why we are doing? Generally we are using it for the test making purpose, test making, sustained release, reduced gastric irritations, stabilization to oxidations, maybe some kind of sustained release, then gastric irritations. So, these all are the purpose for which we are doing that microencapsulations. And what is the final product form? Generally we are making that tablet with the help of acetaminophen, or maybe aspirins. Generally we are taking it as a tablet or in the form of capsules. Some cases we are using some kind of dry powder. So flexible powder, flexible film for thermal mapping of anatomy. So these all are the applications for which we are doing the microencapsulations. Now we are going to discuss about the several process which is related to the microencapsulations. So their process is divided into two parts, one is called the physical methods, another one is called the physico-chemical methods. So in the physical methods we are going to discuss about the vibrational nozzle, centrifugal extrusions, spray drying and spray congealing, then pan coating and air suspension methods, and physico-chemical methods where we are talking about the quasi ceravations, then supercritical carbon dioxide assisted microencapsulations, polymerizations and the solvent evaporations. So these all are the different process by which we can do the microencapsulations. So now first we are going to do or maybe we are going to discuss only about the physical methods, and first one is the vibration nozzle. So in this particular you can see that we are having some kind of concentrating nozzle in which the high fluid is coming, then we are having some electrode, and that due to that frequency or maybe that voltage potential difference, that fluid is divided into small parts or maybe the small bubbles or maybe the particles. So how it is working? Core cell encapsulations or microgranulations, matrix encapsulations can be done using a laminar flow through a nozzle and an additional vibration of the nozzle or the liquid. The vibration has to be done in resonance of Rayleigh stability and leads to very uniform droplets. So it will be divided into small droplets. In liquid form, solutions, emulsions, suspension, melts, etc., it requires viscosities generally 0 to 10,000 megapascal. The solidification can be done according to the used gelation system with an internal gelations, sol gel processing melt or an external additional binder system in a slurry. The process works very well for generating droplets between 100 to 5000 micrometer. So simply we are having that slurry, in that particular slurry in middle also we are having another materials generally which is known as the core materials, and it is surrounded by some kind of encapsulation materials, then it is coming into the liquid form, maybe in viscosity is more higher, then we are just giving the vibration so that that liquid formations can be divided into small particles or maybe small droplets. Next we are going to discuss about the centrifugal extrusions. So what is the procedure? The encapsulations technique consists of a concentric feed tube through which coating material and the core material are pumped separately to the many nozzles mounted on the other surface of the device. So simply when I will come to the next slide, I will show you that how we are going to do this kind of microencapsulation. Simply we are using some kind of machines which is called the extruder, in which we can use that twin screw extruder or maybe the screwing effect, by which we can put our core materials and our shell materials together. Then core material flows through the center of the tube, coating materials flow through the other tube. The entire device is attached to a rotating shaft such that the head rotates around its vertical axis. As the head rotates, the core material and coating material are co-extruded through the concentric orifice of the nozzles as a fluid rod or core sheathed in coating material. Centrifugal force implies the rod outward, causing it to break into tiny particles. By the action of surface tensions, the coating material involves the core material, thus accomplishing encapsulations. The capsules are collected on a moving bed of fine grained starch which cushions their impact and absorbs unwanted coating moistures. So from this particular figure we can easily understand that here we are having some motor, then we are putting the water wall materials, that means the coating materials with water and the core materials, okay. Then we can add some kind of additives also, then we are rotating this one. So by centrifugal actions all the particle will come outside in a rod form, and then due to that surface energy it is divided into the small particles, or maybe we are having some cutters by which we can cut that continuous rod shapes into small particles, and then we can get the material in which the inside is your core materials and the outside will be your inside will be your substrate materials or maybe that core materials, yes, and the outside will be your shell materials or maybe the coating materials. And also here is also another kind of techniques by which we can do this kind of encapsulations. So, by centrifugal force, by rotations, we can make the small micro particles. Here we are having some nozzles. So, simply we are pumping that materials and then the inside will be your substitute or maybe that core materials and the outside is your coating materials. Then the whole thing we are pumping into some device in which we are having small holes, and then that disc is rotating in a very high speed, so that through that holes the small micro particles or maybe microcapsules is coming, and we can collect it into some starch form, so that whatever the moistures or maybe that some kind of contaminants which can stick with that, easily they can absorb by the starch materials. Not only that, when it will come in a high velocity, maybe that can try to stick together. So, we are using some kind of starch, so that it can easily, that impacted can be easily absorbed and we can get the homogeneous structure of this micro encapsulations. What are the advantages? Very long cell life, resistance to oxidations for heat sensitive materials like bacteria and enzymes. There are certain disadvantages also. So, cost in use, increase in carbohydrate in food, large particles generally 500 to 1000 micrometer, limited range of cell materials. So, these all are the disadvantage. Now, next one we are going to discuss about the spray drying and spray coaguling. So, in the spray drying process, microencapsulations by spray drying is a low cost commercial method which is mostly used for the encapsulations of oil, flavors and fragrances. Generally we can use this one for our cosmetic products, or maybe this one for our some food products, or maybe some other means. So, the microcapsules obtained are polynuclear or matrix type. Procedure: cold material is dispersed into the polymer solutions of coating material, which is then atomized and dried up using heated air. Cell material solidifies onto the core as the solvent evaporates. So, simply we are having some polymer materials, we are putting that materials into some solvents, then we are applying a high air or maybe that high heated air or maybe that air pressure, by which the cell material can dry easily and maybe it can evaporate and then it can become hardened, and inside will be your core materials. Next one is called the spray coaguling or maybe the spray cooling methods. So, here it can be accomplished with high spray drying equipment when the protective coating is applied as a melt, microencapsulations of vitamins with digestible waxes for test making. So, generally these all are the applications. What is the process? The core material is dispersed in a coating material melt. Coating solidification is accomplished by spraying the hot mixture into a cool water systems. So, here the two methods is more or less same, only the approach are different. Next, here, so this is called the spray drying, in which spray is equal to aqueous solutions or maybe the hot air. Spray coaguling, spray is equal to hot melt oblique cold air. So, here only this is the difference. One case we are using the aqueous solutions or maybe the hot air, another case we are using the hot melt oblique cold air. So, here the components is that an air heater, atomizer, spray chamber, blower and product collector. So, process variables, generally we can do these concentrations of the coating materials we can vary, nature of the vehicle we can vary, concentration of the core material we can vary, feed rate we can vary, and inlet air temperature we can vary. So, there is certain kind disadvantages also are present. Rapid and single stage operations used for heat sensitive substance. It is extremely well suited to the continuous production of dry solids like powder, granulates or agglomerates from liquid feeds. It is the most widely used in industrial process for particle formations and drying. Now, there are certain disadvantages also. First one is called the porous coating, not suitable for test or odor masking, not suitable for controlled formulations, high production cost. So, these all are the disadvantage of these particular techniques. Next we are going to discuss about the pan coating. So, pan coating is nothing but this is the best example is that when for the structural purpose we are going to use or we are trying to make the slurry, what we are doing? We are having a big chamber in which we are putting the sands, in which we are putting the concrete, in which we are putting the stones, and then we are rotating all the materials into some RPM by which the proper mixing can be done, and we are getting the slurry which we are using for our concrete purpose or maybe some building purpose. So, the process is same is here also. So, here the pan coating process is widely used in pharmaceutical industry and among the oldest industrial procedures for forming small coated particles or tablets. The particles are tumbled in a pan or other device while the coating material applied slowly. The simple thing, we are putting the core material inside the tub or maybe that pan, and then from top of that slowly we are releasing our coating materials, and then we are rotating that tub in RPM so that all the core materials can get the coating materials onto it so that the proper coating can be done. So, process variables include diameter and speed rotations of the coating pan, inlet air temperature, concentration of coating materials, spray rate, nature of the vehicle used for the preparation of coating solutions. So, left hand side corner you can see that here is a big tub or maybe that big vessels are there in which we can put our core materials, and there is one nozzle by which we can put our coating materials. So, the look its schematic diagram is looks like this. So, here we are having some kind of nozzles by which air atomizing nozzles by which we are putting the core materials onto the core materials, and this whole things is rotating in a high RPM. So, by which we can do the homogeneous coatings. So, this is known as the pan coating microencapsulations. Next we can discuss about the air suspension methods. So, this is also one procedure by which we can use the high air pressure. So, here it is also known as Wurster process, consists of the dispersing of solid particulate core materials in a coating chamber. The particles are suspending on an upward moving hot air stream. Fluidizations and coating material, usually a polymer solutions, is applied in the form of spray to the moving particles. The supporting air stream also serves to dry the product while it is being encapsulated. The process can be repeated to achieve the desired film thickness. So, simply we are having that core materials, and top of from the below we are applying a high air pressure onto that core materials. So, it is like that something we are making for using of the popcorn. So, when this core materials is getting a high pressure of air from the bottom, so just it is trying to fly, and the front side wise we are trying to give the core material spray so that the core material can deposit onto the core material itself. So, by this way we can do. So, that is why this method is known as the air suspension method. So, process variable that receives considerations for efficient encapsulation includes melting point, solubility, volatility of the core materials, coating material concentrations, nature of the vehicle, coating material application rate, air velocity for fluidizations, inlet air temperature. So, this is the experiment methods what I am talking about. So, simply we are applying high air pressure from the bottom so that the coating material is flying inside this chamber, and either from the top or maybe from the side we can inject the coating material suspensions or maybe the droplets so that it can easily deposit onto your core materials. So, this is the techniques. Microencapsulations by air suspension is a technique that gives improved control and flexibility compared to the pan coating. This is the added advantage over the pan coating method, and this process is known as the Wurster process. Next we are talking about the coacervations. So, this is also one kind of new technology generally we are using for making the micro encapsulations. So, this technology tells us like that it is a phase separations of one or many hydrocolloids from the initial solutions and the subsequent depositions of newly formed coacervate phase around the active ingredient suspended or emulsified in same reaction media. It is a unique microencapsulation technology because of very payloads achievable up to 99%. It is typically used to encapsulate flavor oil or can also be adapted for the encapsulation of fish oil, nutrients, vitamins and enzymes. So, generally we can use this kind of techniques for preparations of the medicines. There are two methods of quasi-separations available, namely simple methods and another one is called the complex process. The mechanism of microcapsule formation for both processes is identical except for the way in which the phase separations is carried out. So, in this particular case we are doing the emulsions first, then we are changing the pH of that, so that the coating material can be deposited onto that drop wise, then we are using the temperature and the pH so that the reticulations can occur, and by this it can form a gelatin on top of that. So, either we can coat by this technology, we can coat the oil or maybe some kind of liquid particles or maybe some kind of vitamins or maybe some kind of medicines by this kind of techniques. So, here this is the complex quasi-separations method for in which first we are having the gelatin solutions and we are having the oil. So, first matrix materials melting and dissolving, then next case optional inserts for the encapsulated dispersing or mixing is we are putting some kind of gum arabic in aqueous solutions, we are adjusting the pH, we are cooling it down so that gum arabic can be coated by some kind of cross linking materials, and then simple we are washing and we are isolating these microcapsules. So, general processing scheme for microcapsule preparations by complex quasi-separations using gelatin and the gum arabic. So, this is the simple technique of these particular methods. Next we are going to discuss some general process about these techniques. So, the process consists of three basic steps carried out on continuous agitations. First one is called the formation of three immiscible chemical phases: liquid manufacturing vehicle phase, core materials phase and the coating material phase. Next one is called the deposition of the coating. Core materials is dispersed in the coating polymer solutions. Coating polymer material coated around core, deposition of liquid polymer coating around core by polymer absorbed at the interface formed between core material and the vehicle phase. And then the last one is called the rigidations of the coating. Coating material is immiscible in vehicle phase and is made rigid. This is done by thermal cross linking or dissolution techniques. So, these all are the figures by which we can do this kind of process. Next is called the simple polymerizations methods. It is also a randomly and most easily used method by which we can do the coating of our nanofillers or maybe any kind of core materials. So, what this process tells actually? A relatively new microencapsulations method utilizes polymerizations techniques to form protective microcapsules coating in situ. The method involves the reaction of monomeric units located at the interface existing between a core material substance and a continuous phase in which the core material is dispersed. The continuous or core material supporting phase is usually a liquid or gas, and therefore, the polymerization reaction occurs at liquid liquid, liquid gas, solid liquid or maybe that solid gas interface. So, any phase by using the core materials or maybe by the coating materials we can do this kind of micro encapsulations. So, what is that? First is called the interfacial polymerizations. The two reactants polycondensation meet at an interface and react rapidly. In situ polymerizations, in a few microencapsulation process, the direct polymerization of a single monomer is carried out on the particle surface. Matrix polymer, in this case a core material is embedded in a polymeric matrix during formations of the particles. So, these all are the three different methods by which we can do this polymerization process. Next one is called the solvent evaporation methods. It is also a one kind of microencapsulation techniques. What this techniques is telling us? It is the techniques which are carried out in liquid manufacturing vehicle, which is prepared by agitations of two immiscible liquids. So, simple two liquids which we are not mixing properly, we can take for this particular purpose. The process involves dissolving microcapsule coating polymer in a volatile solvent which is immiscible with the liquid manufacturing vehicle phase. A core material, generally drug, to be microencapsulated is dissolved or dispersed in the coating polymer solutions. With agitations, the core coating material mixture is dispersed in the liquid manufacturing vehicle phase to obtain appropriate size microcapsules. Agitation of system is continued until the solvent portion partitions into the aqueous phase and is removed by evaporations. Results is hardened microspheres which contain the active moiety. So, here the solvent evaporation process, first we are taking the core materials, then we are dissolving that core materials into or maybe dispersing into some medium, then we are making the coating polymer solutions, and then we are doing some kind of agitation process, so that liquid manufacturing vehicle phase is forming, then we are doing the heating, and then we are evaporations of the polymer solvent, and by these methods we are doing the micro encapsulations. So, this is the whole diagram that how we are following the solvent evaporations micro encapsulations technique. So, here also the various steps are available. So, first is called the formation of a solution or dispersion of the drug into an organic polymer phase. This is the step 1 which we are doing. Next steps, emulsifications of the polymer phase into an aqueous phase containing a suitable stabilizer, thus forming a oil water emulsions. So, here oil and water, two immiscible liquids which we are taking for this particular purpose, as already I have discussed. Next, removal of the organic solvent from the dispersed phase by extraction or evaporation leading to polymer precipitation and formation of microspheres. So, in this particular case we can see that we are adding the drug and polymer in organic solvent, then we are putting into some vessels, then we are doing the continuous stirring of oil water emulsions, then we are doing the solvent evaporations, and then after that we are getting the recovery of the micro/nano particles. So, some important factors that must be considered in solvent evaporation techniques are choice of vehicle phase and solvent of the polymer coating. These choice greatly influence microcapsule properties as well as the choice of solvent recovery techniques. The solvent evaporation techniques is applicable to a wide variety of liquid and solid core materials. Next is that called the supercritical carbon dioxide assisted micro encapsulations. It is also a one kind of latest technology by which we can do this kind of modifications. So, compressed carbon dioxide in liquid or supercritical state is attractive as a solvent in micro encapsulation technique. Carbon dioxide is non-toxic, inflammable and inexpensive. These all are the added advantage by which we are using the supercritical carbon dioxide. High volatility of carbon dioxide allows it to be easily separated from polymeric materials by lowering pressures. Supercritical fluid state is reached when the temperature and pressure of the substance are above its critical temperature and pressure. For carbon dioxide, the critical temperature is 31 degree centigrade and the critical pressure is 74 bar. So, supercritical is more than this temperature and more than this critical pressure. So, here that if we see the pressure temperature diagram, so we are having the solid phase, we are having the liquid phase, and we are having that gas phase, and this point is calling the supercritical region, where we can get the pressure of around 73.8 bar and temperature is around 31.1 degree centigrade. So, beyond that the formation is known as the supercritical formations. So, steps in impregnations, how we are going to do this kind of techniques. The polymer materials is exposed to supercritical carbon dioxide for a while. The solution or additives in carbon dioxide is introduced and the solute is transferred from carbon dioxide to polymer solutions. Carbon dioxide is released and the solute is trapped in the polymer solutions. So, this is the techniques. So, here first material we are taking as a GMAOT plus in acetone PVM or some kind of MA polymeric solutions. So, first is acetone and second is the organic solutions. Then we are putting it into the supercritical carbon dioxide chamber, in which we are making these small nano particles or maybe that micro encapsulations materials. So, here we are having some kind of collecting materials, and from this particular chamber we are maintaining the supercritical carbon dioxide inside the chamber, and right hand side it is showing the FESM image, that how we are getting the final view of that micro encapsulation techniques. When the suspension of polymer particles in water are exposed to supercritical carbon dioxide with the presence of additives in water, the transport of additives into polymer particles can also be enhanced. After releasing carbon dioxide, additives can be trapped in colloidal polymer nanocomposites or maybe that nanoparticles. Next is the summary. So, here briefly we can tell that what we have discussed on this particular topic. So, here actually we have discussed that what is the microencapsulation techniques, by which method we can do several kind of microencapsulations. So, based on our requirement, based of our materials, based of our core materials, based of our coating materials, we can choose the best microencapsulation techniques, and also the lecture covers a brief introduction about the different process used for the microencapsulations. So, this is the whole summary of the microencapsulation process, what we are doing for surface engineering methods. Thank you.